Hi everyone. Okay, so we're going to talk about adding and subtracting rational functions. And I put a couple of examples up here, but I really wanted to go over what to do when you're adding and subtracting fractions. We have done this before. I mean, this is not technically new material until you get into the rational functions, but you should know how to add and subtract a fraction. One of the most important things in adding and subtracting fractions is to get something called common denominators. In this case, we look for factors that are the same and we try to multiply using the least common denominator, the LCD, to not give us too much to reduce later on. So what I mean by that is if this was a 6, it's a 5, but if this was a 6, then we would multiply the other fraction by 2 so that both of our denominators were 6. In this case, we can't multiply one of the fractions by something and not multiply the other because I cannot multiply anything by 3 to get 5. So what we do to find that least common denominator is we take 3 and multiply it by 5, and that will give us 15. So this LCD is what we want. We want both of our denominators to be 15. So in order to do that, I have to multiply the denominators by what is missing. So in this first one, I'm multiplying by 5. And if I do it to the denominator, I must also do it to the numerator. The second fraction, I'm going to multiply by 3. Once again, if I do multiply by 3 in the denominator, I must multiply by 3 in the numerator. Multiply straight across. 5 times 1 is 5. 5 times 3 is 15. Plus 2 times 3, which is 6. And 5 times 3 is 15. Now that the denominators are the same, we can combine the fractions over that same denominator by adding the numerator, or subtracting if there was a subtraction. Once you do that, 5 plus 6 would give me 11, and 11 over 15. And then you would see if you can reduce if possible. This is old what we would do with fractions. Like this is something that we should know in our level of math right now. However, what we're learning really today is how to add and subtract rational functions. So this rational function down here, you want to take a minute and pause and write it down. But this rational function here is a very similar process to our fraction above. Now, one thing that I would make sure everybody knows, and one thing that you still want to do with all rational functions, is you want to factor if possible. In this case, we cannot factor because the denominator of the second fraction, 3 and 4, have no common terms. So now we want to find our LCD. Now our LCD is going to be found very similarly to what we did above. We're going to take the factors from each fraction and multiply them together. Well, the factor in the first fraction in the denominator is x minus 3. So we're going to take x minus 3 and multiply it to the factor in the second fraction, which is 3x plus 4. If there were multiple factors in a fraction, we would use all of them, listing the factors at least once. So I have x minus 3 times 3x plus 4. Now the beautiful thing about this is you do not need to distribute, and I would suggest not distributing. Not distributing is going to help you simplify easier later on because you will have it already in factored form. So don't distribute the denominator, okay? And that's important. Don't distribute, not distributing the denominator. Now, how do I multiply in what my LCD needs? So this is what we call our least common denominator. And what we want is each fraction to have this denominator. So what you need to do is multiply the fraction, each fraction, by the denominator that it's missing, the factor that's missing. So in my first one, I have x minus 3, so I need to multiply it by 3x plus 4. And I'm going to do numerator and denominator just like I did in the problem above. Then my second fraction is missing the x minus 3, so I'm going to take and multiply numerator and denominator by x minus 3. Now I have said do not distribute the denominators, but you should want to distribute the numerators because the whole point of this is to combine like terms and see if we can simplify later on. So move this up a little bit. Okay, now I'm going to combine this first fraction. If I combine this first fraction, I have x times 3x plus 4. That's going to be 3x squared plus 4x. The denominator is going to stay 3x plus 4 times x minus 3. And I'm not going to distribute it, and I'll show you later on why, okay? Now, the second fraction, I'm going to distribute the 2 times x minus 3, which is 2x minus 6, divided by 3x plus 4 times x minus 3. Now, the only thing that we want to watch out for is when we combine the fractions into one. You write it as a single fraction with that denominator staying the same, just like we did above. I apologize. Okay, so we have the same denominator here, but what we want to do with the numerators is to make sure that if you have an addition, obviously you can add, but if you have a subtraction, that subtraction needs to be distributed to this numerator here. Okay, so we want to subtract both terms, not just the whole thing. So what I usually do is I say 3x squared plus 4x minus, and then usually I put it in parentheses, the 2x minus 6. That way I remember to distribute that negative. We distribute the negative. I get 3x squared plus 4x minus 2x plus 6. A lot of people would put negative 6 on accident because they forgot to distribute that negative, so just please make sure you don't do that. Now we have successfully kind of combined these two fractions. The only thing left to do is to simplify by adding like terms. In this case, 4x and minus 2x gives me 2x plus 6. And then the only thing left to do is to see if it simplifies. And remember your rules for simplifying: factor, domain, and then reduce. So to simplify this, we want to see if the numerator factors. To test factoring, we would take a times c, which is 3 times 6, which gives me 18. Factors of 18, 1 and 18, 2 and 9, and 3 and 6. None of those factors, positives, none of them will be adding to 2, so therefore it does not factor. So this is my final answer. That's a quick and easy test with any trinomial, is to just really quickly determine if it factors or not. And then you're done. I have two more examples that I want to work with you, both of them kind of giving different pieces of this. So this is our first one, and now let's move on to our second example. Okay, for example 2, a little bit different from the first one. The first thing I would always suggest is to see if it factors. And in this case, the denominator here should factor. So we want to factor the denominator. I'm going to leave the first fraction alone and factor the second fraction. This factors to x minus 2 times x minus 1. Now, when we're finding our LCD, you're going to list the factors. List all of the factors. Okay, so in my first fraction, I have x minus 1, so I need to list it. In my second fraction, I have x minus 1 and x minus 2. While I already have listed x minus 1, I don't need to list it twice. So the one I'm going to list now is x minus 2. The only time you would list x minus 1 twice is if it was twice in a single denominator. So you're going to list x minus 2 and x minus 1. So this is the denominator that I want, and now I need to multiply in the factors that I am missing. In the second fraction, I'm not missing anything. But in the first fraction, I am missing x minus 2. So I'm going to multiply top and bottom by x minus 2. Once again, we're going to multiply, distribute the numerator, but not distributing the denominators. So x times x minus 2 is x squared minus 2x. And then I have x minus 2 times x minus 1. In my second fraction, it stayed the same, nothing changed. Over that x minus 2 times x minus 1. Now I'm ready to combine my fractions because I have common denominators. So if I combine my fractions and I get x minus 2, x minus 1 is my denominator for the one fraction, my numerators can get added together. And because it's addition, I don't have to distribute anything, so I can just kind of list everything. My fraction from my first was x squared minus 2x, that went here. From the second was 2x minus 1, that went here. And now we can combine like terms. In this case, my like terms are negative 2x and 2x, those will cancel. And in my fraction, I have x squared minus 1 over x minus 2 times x minus 1. Oops, sorry, I'll look that up. Now, this is where you want to make sure if it simplifies. Once you have a single fraction, you go through your simplifying rules. Factor, domain, reduce. So in this case, I'm going to factor the numerator, and it does factor by difference of squares. This would factor to x plus 1 times x minus 1. My denominator is already factored. This is why I tell you do not distribute the denominator. It makes this step a lot easier. Before I reduce, I can go ahead and set my domain. X cannot equal 2 and x cannot equal 1. We'll write it in a second. And then when we reduce what we have in common in the numerator to denominator. That would be the x minus 1s. So my final answer is x plus 1 over x minus 2, where x cannot equal 2 and 1. Okay, that would be our second example. I do have one more example, and that one more example is a little bit more in the denominator. So right here, give it a second to catch up. There we go. Now, with this one, once again, give you guys some steps. We want to find and we want to factor everything, okay? Always with these things we want to factor. Then we are going to want to find our LCD, okay? Multiply in our LCD to combine. And then the last step is going to be the simplifying part. And the problem is the simplifying will not always work, but remember when you are simplifying, we always factor, set our domain, and then reduce our problem. Now, factor the numerator and denominator if possible. If you want to take a minute and pause and see if you can get the right answer, go ahead. I'll give you a second to pause. Otherwise, I'm just going to go ahead and start. So we're going to factor that denominator. I'm going to leave the numerator alone because I can't factor it. Factor out x, I get x times x minus 2 minus x plus 2. I can factor out 2 here, so that's 2 times x minus 2. Now my LCD. Remember to set your LCD. You want to take one factor or factors from every denominator. So in the first one, I have x and x minus 2. I'm going to list each of them, x and x minus 2. In the second fraction, I have just a 2 and an x minus 2. Well, the x minus 2 is already listed, so we're going to just list the 2. So I want to multiply everything by 2x and x minus 2. My first fraction, the only thing missing from my LCD, if we're comparing the two, is that 2. So I'm going to multiply top and bottom 2. In my second fraction, the only thing in the denominator missing from my LCD is x. So I'm going to multiply top and bottom by x. Multiply those numbers in. 2 times x plus 2 would be 2x plus 4. And we're going to leave the denominator 2x times x minus 2. Multiply in x, I get x squared plus 2x. And leave the denominator 2x times x minus 2. Once again, I'm subtracting, so remember that we have to take and distribute that negative. I'll go ahead and do it in just this one step. So this is going to be 2x plus 4 minus x squared minus 2x over 2x times x minus 2. And then we can combine. If I combine this, I get negative x squared plus 4 over 2x times x minus 2. Now this looks done to me, and it can very easily look done to you, but please make sure that when you get to this point, you really think about it, because there is more we can do. You go, oh, that looks finished, but it's really not. So remember, your first term should never be negative, so let's go ahead and factor out a negative, leaving us with x squared minus 4 over 2x times x minus 2. Now, if you got this far and you didn't factor out the negative, I commend you for getting this far, but I just wanted to remind you that you can and should factor out that negative, because if you do, you should see that this is a difference of squares and continues to factor just like it. So we want to take out, we have that negative out, and we want to write this as x plus 2 times x minus 2. And now we have something that will simplify. Cancel my terms, x minus 2, and I have negative x plus 2 over 2x. Once again, x cannot be equal to 2 and 0. Okay, that is my last example. So there is an assignment for you on your Canvas. Go ahead and do that. It should be labeled the same as this lesson, which was adding and subtracting rational functions. I wish you all the very best. Hope you're having a great day.